We're going to cover a lot of various topics, and we're going to start by learning how to create low-res geometry using various methods, and then we're going to look at ways to create UVs in Houdini, start learning about texture baking using Mantra, and then learning how to displace the geometry back in Arnold at render time. And then we're going to start looking at shading in Arnold, learning about LUTs and how to install the ACES workflow, and then start shading some of the elements that we've previously created and try to push that to the limit. So hopefully you guys will like this, and let's get started. In this video, I wanted to talk about the UV unwrapping in Houdini and the various tools and options that we have available for us by default. And I have a sphere here, and I'm going to go over the three basic tools that I use most of the time, 3 or 4. And the first one is called UV project. If you hit tab, you can see there's a whole section for the UV tools. And the first one is the UV project, and this is a very simple way of projecting the UV coordinate. And you can hit space 5 to switch to the UV view, and you can do that also by going under the clicking here, set view, and then UV viewport. And you can see we have a orthographic projection applied to the sphere now. The cool thing about this node is there is this initialize feature, and that will try to fit the object into 0 to 1 space. So if I hit initialize, you can see now we're doing a orthographic projection, and there is other options as well. There is a polar coordinate, and this basically creates a polar coordinate. It's a spherical mapping, and you can view the UVs using a UV quick shade. This is an OpenGL drawer that to just show you the UV. It doesn't store anything on the texture itself, and it adds this shop material path to tell the viewport what texture to use. There is one that comes with Houdini that I like to use most of the time, and if you go under the Houdini install hips, there's this UV grid color, and I prefer to use this. So now we've created a UVs. We can also, what else is there? There's cylindrical, toroidal, and plastic wrap. I'm not so sure what's the difference in all of these. The main one that I use, this one looks interesting, but honestly I've never used it. It looks like it has a lot of distortion in this sphere. The other one to use is the UV texture node, and this one has more options, and it can create UV coordinate for NURB surfaces as well using the rows and column, and that will give you a perfect 0 to 1 space UV unwarp of whatever surface you have, whatever NURB surface you have. It's very similar, and I use this most of the time to create a projection along a specific axis. When you have a grid or something, that's the one I use. And then what else? And then we have the more advanced tools, which is let's leave this on, which is the unwarp. And this basically does a 6, 4, 5, 6, 8 planar projections. So you can see it created a 6 squares, 6 sides projection for the spheres, and you can control the spacing between them. Now you can see it's not making good use of the space. It's not going to get a lot better. You can change it to stretch to fit that, but there is also a UV layout node which will try to place these in a way that fits better the space. So let's see, and I believe, yeah, you can scale them, so you can choose the distance. This generally helps a bit when you have a lot of object, but in this case it's not helping a huge deal. And then the next one is the UV pelt. There's the UV flatten and the UV pelt. They're both different, and both of them requires an edge selection. So I'm going to go back to the sphere and create a group node. And this is just a brief intro. We're going to go back and use them to actually unmorph meshes properly, and that will in those examples we'll dive in more and understand how to use these nodes better. So let's select, just selecting a ring here. Let's do it continuous. Cool. And then I'm going to hit enter, and let's call this edges. And let's use the UV pelt first. And this is very useful. I ended up using this node a lot. I will try to flatten the node, the UV coordinate. And I prefer to use the turtle toot barycentric. And with 200 or more iterations, you should be able to get a very uniform unmorph of that surface. So this is a very handy node. And then there's the UV flatten as well, which requires a UV sim. And this is the typical unwarping. And let's connect this here. And it will unflatten the object, but because we have a continuous ring, it's gonna generate two surfaces. So let's change the selection. Let's do something like this, with just one side. Yeah, and let's hit enter. Let's use this, and it should unflatten the surface without separating the blocks. And there is no options for this. It's either going to give you the result or not. And then you can add additional seams if you want to by selecting them in the viewport. So we could add this. Sorry. We can add this as a second selection. Yeah, it's not helping either in this example, but basically you give it a specific edge and it will try to unflatten the geometry based on that. It's different than the UV pelt for sure. You can see this one produced a single object versus this one. And in the next video, this is a brief intro again. We're going to in the next video, we're going to learn about displacement extraction, maps extraction, and then we're going to start creating UVs for the geometry and learn how to use these nodes in concrete examples. So in this video, we're going to learn a bit about the texture baking or maps extraction, and I wanted to explain the idea behind it. And I have two spheres here. One is a very high-res sphere with 144,000 points that I displaced. I added a little bit of noise, so it's this, and just recomputed the normals again. And then I have a low-res sphere, which is this guy. Doesn't have a lot of points. And the idea of the maps extraction is that I templated this, is that we want to compute the difference between these two surfaces, the low-res mesh and the high-res mesh, and then store that difference in a map. And we can do this even here. We can do the extraction, the difference even in SOPs. But the problem is we don't have a lot of points in the low res. So if we're going to compute the distance between this point and this surface and store that as a displacement, which is what's going to happen when we do the actual extraction, we don't have a lot of points. We're not going to be able to accurately represent how the surface is. And that's where the render, Mantra comes in. We have to use the renderer to extract a very accurate information about the difference between the two surfaces. And when we render this, it's going to subdivide it into a subpixel level, and it's going to, Mantra is going to use this low-res geometry and start shooting rays. It's going to shoot rays in a hemisphere, and then the first point that hits that ray from the high-res mesh, it's going to get the distance, how far that ray traveled, and then store that in an image. And in this case, it's going to store a negative value that pushed this point to be here, and then a positive value for anything that is underneath. So for example, you can see the surface is underneath the high-res detail, so it's going to store positive displacement. And that's the idea, basically. We need a low-res mesh and we need a high-res mesh. And the more difference, the higher the difference between the two surfaces, the higher the chance of losing some details, because there's a chance of error that gets higher and higher the more difference there is between the surfaces. So for example, if we pushed this surface, the high-res one, too far, and let me copy this one more time so let's do it one more time. So if we started pushing the surface too much and start getting cavities, it's really hard for the low-res surface to understand what details to use, because there is two of them. When we get cavities like this and we have a low-res mesh, it's going to shoot a ray, and that will hit the internal part of that high-res geometry, and that's where we start losing details. So we have to be very careful about how much we push, how much difference there is between the low-res and the high-res. And in general, we don't, this is an illustration example, but we don't do this we don't do this in production. Generally, we take the high-res mesh and then we generate a low-res version of that is closer in terms of silhouette, that tries to matches the high-res version, something like this. For example, just using a remesh, you can see we still have the majority of the silhouette of the high-res version, but we're missing the fine details. And this will be a much easier case to use the displacement extraction, but I wanted to use a more extreme example to show you guys. Now I want to use the UV project node. Was that it? The UV texture node? Sorry, the UV project, yes. So let's put down a UV project, and I'll explain why in a second. And I want to unwarp this polar. Cool. And I'm not so sure if we're seeing. Okay, yeah, I wasn't sure if we're getting overlapping faces or not, and it looks like we're not. So the reason we need a UV coordinate on the low-res mesh, it's because Mantra is going to use that to start shooting rays, and then whenever it finds a difference, it's going to use that UV coordinate to store the information as a texture to disk, and that will contain, for example, the displacement. We can also extract a variety of other things, but we'll leave that for a more advanced section that we're going to use for games in general. In this video, we're going to just focus on the displacement extraction. And I have the low-res mesh and I have the high-res mesh. And there is various methods for extracting the displacement. We're going to use the default one. It's called UV to surface. And there is another one that's called trace displacement and UV match. The UV surface starts by analyzing the UV coordinate and shooting rays based on the UV information. The trace, it's going to do a similar render, basically similar to how Mantra starts rendering an image, and then every shading point is just going to shoot rays. So the UV, there is not so much difference between UV to surface and the trace displacement. The only difference is the UV to match compared to all the other method. And the way the UV match works is it requires a UV coordinate on the high-res mesh as well. And the reason for that is because it's going to use this point, for example, it's going to get its UV coordinate, and it's going to try to relocate that same point, and using the UV coordinate, it's going to try to relocate it on the high-res mesh and compute the difference. This provides a much more accurate capture, but we can't do it at the moment. It requires a UV on the high-res mesh, which we're not going to be able to generate easily. So we're going to use the UV to surface method. And what I've done is I have the low res mesh and I have the high res mesh, I simply imported them into these two guys. So low res, high res. Okay. And then let's have them on. And if we go back to here, let's create, we're going to go to the out context, and it's actually a render. So if we hit tab and type in bake texture, and we're going to use Mantra because Arnold doesn't have a great way of baking textures, and Mantra is great at doing that, so we're going to use it for the time being. I'm going to change the format to TIFF and tick on displacement. And what it's going to do is it's going to save the file as a RAT file, which is the Houdini native format, and then from there extract the TIFF version. And then if we go under the baking tab, let's see, under the unwarping tab, these are the three methods I was talking about. So we're going to keep it to UV to surface, and maybe later we'll try the trace closest. And there is also this diffuse fill option. When we separate, let's say, let me go back here and explain what that's going to do. So we create a UV unwarp. And let's take a look. So here you can see there is edges on each of these sides, and sometimes we get errors on these boundaries, and it's nice to expand the UV the bake texture just a couple of pixels to add padding for these areas, and that's where the fill comes in. So you can say diffuse fill, it's gonna give it a specific color, or you can say border expansion, which I prefer to use. And this is how much pixels you need. I'm gonna leave it at 2 at the moment, and the only thing we need to add is the UV object, and this is the low res mesh, and it has to have a UV, and then the high res version, which is the high res version. And then this is the resolution, that's all we need, and we hit render. And it's rendering now, so we'll be done in a second, because it's not that complex extraction. And the more options here, the slower the render is going to be. And we're going to talk a bit more about this as we progress through the workshop in this week. So let's take a look at what we have. Not this one, sorry. Cool. So I have, this is the image, and you can see we have the extraction, we have the displacement map. Now all these values are negative, that's why we don't see them. Here you can see they're negative values, and basically this is the result that Mantra gave us. Now I'm going to leave this here. I'm going to make a copy of and call this UV to surface. That's the method we used. And I want to run another test with the using the trace closest surface. And it should be done soon. And the way the expansion works, first Mantra does the render, saves it as a RAT file, then does a first extraction to give you the TIFF format, and then another post-process to take that TIFF file and expand its boundaries. So let's take a look at what we have here. Cool, so this is the trace, and you can see it's working much better. And this is you can see the result is much better already. And the UV to surface method, the reason we're getting the clamp, let me go back. Hopefully I can explain this. One second. So this is done using the trace closest, and this is done using the UV to surface. Okay, now see how it is clamping here? See that issue? It's because it's not knowing how to look up for the other surface. It's not able to capture the details. It doesn't have a good understanding of how the surface works. And I'm not sure how we get the best result out of the UV to surface. Honestly, it didn't work for me, but I wanted to illustrate it. And the only method I'm using currently is the trace, and then the UV match. And I'm going to explain the difference. So when we have the two surfaces, the way the trace works is it's going to, for each point, it's going to open two cones. One cone of 180 degree, looking along the normals, facing this direction here, and then another one facing the inverse normal, so it's going to shoot downward. And then from those two, it's basically going to create a hemisphere, or a complete sphere, a 360 degree sphere where it shoots rays in all direction. And then the closest point to that surface, it's going to use it as the target. And then it shoots rays, and then when it hits the high-res surface, it's going to capture the information. It's going to capture the distance in this case. And that's what the trace is. But it's not a great method when you have a very intricate cavities. It doesn't give you, it's not going to look up or find the correct value. And then that's where the UV match comes in. The UV match allows us to capture a lot more information between surfaces that have very complex deformation. But it's really hard to create the high-res, the UV on the high-res mesh. And I'm going to show a solution for that. It's a two steps workflow that requires two baking, but I'm going to explain it here. And the UV method, the trace method, is also able to capture a lot of details. So we have the result here, and what I want to do is I want to do something bizarre. It's actually very simple, but it's very simple in Houdini, but in other apps this is very complex. So okay, so what I'm going to do is, let's forget about this, okay? And let's say we have this low res mesh, and I think I'm gonna pause here and we'll continue in the next video because it's getting long. So we'll continue the second step of this workflow to have a full workflow of how we can capture any maps or extract any maps that we need between complex meshes. In this example, I'm just using sphere to illustrate the method, and then hopefully we're going to apply it on a much more complex mesh. So we're going to try and create the workflow to fully utilize the UV match method that will allow us to create extract very high-res maps between a low-res version and a high-res mesh. So we've extracted this map, a displacement map, using the the trace closest method. And what I want to do is I want to take this low-res mesh and I want to subdivide it. Okay, I'm going to subdivide it 4 times. And again, we're going to forget about the low-res version. And then I'm going to create a point VOP. And the idea is I want to apply this displacement map back onto the low-res mesh after subdivision, and I want to displace this using that map and see how far we are from this surface. And I'm going to dive inside, and we need a color map. We need to import the UV, so I'm gonna vector to float that, connect these two guys, and let's expose the map. And then we need a displacement, a displace along normal, and the amount is going to be this. Let's actually use just one vector because it's a grayscale. And then let's connect this to the displacement. Now the UV coordinate here, if we look at it, the UV coordinate is a vertex, and we need to promote that. So attribute promote from vertex to point, Cool. And it's displacing the surface now using the mandrel image. We don't want that. So let's use our map. You can see we have two of them. We have this one. This is the original one, and then it extracted a TIFF file, and then that TIFF file got expanded boundaries. So this is the one we need to use. And if I connect that, boom, we have perfect UV, perfect displaced sphere. And this is the low res. Again, this is the low res with the UV. We've used it to extract the difference between this and this. And this is what we have now. Now look at this edge here. And this is where that border comes in. You can see there's a little bit of issue there because of the UV and the distortion. And I'm going to change the attribute promote from average to first match. Hopefully that will get rid of that attribute. The reason that's happening is because the vertex attribute is the UV coordinate is a vertex attribute. And that point is shared between two areas. So see, for example, this point here, it has one UV coordinate. Sorry, this point here is the same as this one. They're both the same point, but they don't share the same UV coordinate. So setting this to first match solves the promote the UV coordinate accordingly. Now let's increase this a bit more, maybe 5. Maybe this is too much. Fine. So I'm gonna do another bake with a higher resolution. I want to capture more resolution before I start subdividing this, but you can see already we're getting a lot of details now. How far are we? Yeah, it's fine. Yeah, let's set it back to 4. And let me pause for a quick second and do another extraction at 4K. So I'm going to set this 496 and I'm going to hit render, and I'll pause and come back when it's done. Okay, so now the bake is done and I have the 4K map. I'm going to load that. I saved it to a different folder, V2, and I'm going to load this version here. And I've subdivided the mesh 5 times. Cool, so it's displaced. It doesn't look like it changed that much. Maybe the map didn't refresh. Sometimes changing the viewport helps, refreshing it. Cool, so now we have the two surfaces, and this is the result that we would get from the render. If we were to take this mesh exactly as it is, using any renderer, any tool to do render time displacement and use this texture, we will be getting this result because this is exactly what's going to happen. And let me recompute the normals just to make sure. And I want to compare this with the original, just do a side-by-side comparison. Okay, and let's transform this so we can view them both at the same time. And let's move this 10 units. That's too much. And let's template this. Okay, so this is the original mesh, and this is the displaced. And you can see we're getting a very close match. Now see how these curvatures are not being captured. That's because of the cavity that we talked about. See here, it's not knowing how to capture that, and this is very normal because it's really hard to capture anything that has basically a concavity, which is happening here. So we need to be very careful whenever we bake. And remember, we started off with a very different topology, which is not the case. Most of the time you would have something that still has some of this details in there, so probably capture a bit more. And you can see we're getting the push in as well. Anything that is and in the other direction, we're getting that as well. So the method that I have, I'm actually going to, let's leave it at that. So the method that I have is when we need to capture more accurate details, we need to use the UV mesh. And now that we are very close to the high res mesh, right? We're not too far from that. And maybe I can, let me make a copy of this, and I want to increase the resolution of this. Let's say 250. Okay, you can see now we're getting even more details. Let's go even higher. Let's try 300. Okay, so the last thing that I want to do is I want to do a ray between this, the high-res version with the displacement, and this one. So I'm gonna move this here. I'm gonna put down a ray, and let's ray the two together, and let's turn this off. We want them to be on top of each other, and let's put down a null. Okay, so now we're raying this version here, this version with this mesh, which is, again, this is the original mesh with the noise on it, the high-res version. This is the low-res version with the displacement applied. It's the low-res subdivided, and then we added the displacement back. And the last bit I'm doing is trying to capture any extra difference using a ray. And what the ray is going to do, it's going to just project to the nearest. And I'm going to make sure that it uses that. So I'm going to change it, instead of project ray using the normal direction. I don't care what direction it's going to use. I just need the minimum distance. You can see now it's bringing back a little bit of details. Now this example may not illustrate all of this, but in some other example with more extreme cavities, we're going to be able to bring some of that back. Now the main thing that we have here is that we have a mesh that is high res, super high res, and it has the UVs. So this is the main thing that I was going after. And now I'm going to create a null here and call this high res with UVs. Okay, and then I'm going to copy this and call this, we have the low res. I'm not gonna do anything about that. So let's create an object merge. We need the low res. Actually, we don't need the low res, we have it already. So I need this, and I'm gonna preview it. So that's our high res mesh with from the low res. It has the UVs. I'm gonna go up and create a new geometry node and call this high res with UVs. Okay, I'm gonna dive inside and let's paste that node in there. So this is our low res. Make sure we're getting the correct stuff. And this is the high res with the UV. Now let's go back up here and copy this. I'm going to call this bake using UV match. And let's go under the unwrapping method and change this to UV match. Now we need to change the high res to have the UVs as well. So high res with UVs, and then the low res. And I'm going to leave this at 4K, and I want to extract something else. I want to extract the vector displacement. And the difference between the vector displacement and the displacement is that when Mantra computes the difference between the low res, it's going to use that hemisphere to find the closest point. But when we use the UV match, it's going to actually try and locate the points. Exactly. So if we have a point that starts here but then is shifted all the way here, we're going to get a vector pointing in that direction. But with the displacement, we cannot capture that. We cannot have anything that moves in a different direction other than along the normal. So the vector displacement tells us, it knows how it can push points in the different directions. That's the main, this is a 3D, a vector displacement, it has X, Y, and Z, and then the displacement just along the normal. So I want to extract that as well. And we need to make sure that we either use a TIFF because it's a 32-bit file. So TIFF, EXR, and or PIC or RAD file. I'm gonna stick to TIFF file for now. I'm gonna hit render, and then we'll continue looking this in the next video. So now that the bake is done, I want to apply the new displacement extracted back into the mesh and compare the result with the original one. So I'm going to browse to the new file, and it is this one here, and this is our new result, and let's compare this with the original mesh. And you can see already it's much closer than the one we had before. Actually, let me merge them one to one. Let me merge them and then let's compare them. And the vector displacement is, for some reason, it's not working in the viewport here, and we're going to get back to it when we start doing the rendering, and that's what we're going to look into it deeper because that's basically where we need it. And overall, most of the baking techniques is going to be for the in-games. With Arnold, we're going to be primarily using the high-res meshes, but I wanted to explain some of the displacement extraction techniques and how we can get the most out of it by building two-step processes. Let's set it to 1. Cool, so you can see it's very close. I mean, if we don't see this and just look at this original mesh, we're very close. We're doing a great job with the baking at the moment. So this is basically it. In the next video, we're going to look at how to create UVs for one of the meshes and run it through the baking process and try to reproduce the same thing now, but we'll go much quicker than that. I've done a small change here. If you guys remember, there was a promote node that promotes the vertex attribute from the UV attribute from a vertex to point. I changed that now, and inside the point VOP, I'm using the import vertex attribute here, and basically I'm setting the first input and then typing UV here, and this will automatically import the vertex attribute, and we don't have to promote it. I needed to do that because in order to bake this correctly, it needs to be a vertex attribute, and to restore the point, to promote the point back into vertex is much trickier. So I resorted to this, which is a much cleaner way of doing it. So I think that's pretty much it. I hope you guys understand the two-step process. Again, this is only required when the first bake does not give us what we want, and there is a case where we're going to run into that. It's more for week 8. We're not going to cover it this week, and hopefully, let's see, probably week 9 for the in-game stuff when we start doing more advanced baking that we need for the real-time rendering. In this video, I wanted to talk about the proxy geometry generation and how to create low-res geometry from high-res data. And I have this mesh here. It's 3 million points. And if you guys remember, we started the creation of all of these using volumes. And I want to treat this geometry as if we don't have any inputs. We've never had the original scenes, so that this process, it can be applied to any other meshes that you guys may receive or have to work with in Houdini. And I'm not going to rely on having anything previously done because we are the owner and we've created this. I want to treat this as a fresh start, so I can show you all the methods. And what's available in Houdini? There is a poly reduce node, there is a remesh node, and there is a VDB from Polygon. So these are the 3 options available for us. And each one of them has different advantages and different disadvantages. And the main thing that, I'm actually not so sure about this. The main thing that we need to know about all these workflows is that we're going to be losing attributes. when we remesh the data, and let's say we have a UV coordinate here, it's going to be really hard to maintain that to the low res mesh. And luckily with the projection, with the extraction workflow, we're going to be only needing the low res to be UV'd. And with the VFX workflow with Arnold, we're not going to be really using the UVs to create textures. We're going to rely on the triplanar. So even though I'm going to explain how to create various UVs, we're not going to be using them 100% in this workflow. And whenever you're going to optimize the mesh, again, imagine you're going to be losing attributes. So you have to find ways to transfer that back. And again, other than the UV coordinate, we don't have anything to worry about. And the UV coordinate is always generated on the low res, which is the result of this process. So let's take a look at this. This is very useful for when you have, when you work on in games and you have a specific poly count that you need to reach. This guy has a very useful feature. I just disabled this. So you can say I want to keep 100 primitives or 1,000 primitives or something like that. You can also use a distance from an object if you have a scene and you want to low res everything based on a specific location. You can use that to generate LUTs basically. And then you can also give it a specific set of edges that you want to maintain. If you have a box, for example, you can select that box and give the edges here. And I personally don't have, I didn't have to change these guys a lot. I generally use, let's say, start with 10% and take a look at the result and see what kind of polygons I'm getting. Will that mesh be enough for in games or to be subdivided and used? And when the primary use for this is going to be Arnold proxy preview, and later we're going to try and reuse the same thing for the in-games as well. But I'm not gonna go into details for that yet. So the use for us is going to be a low res that we can UV easily, so it doesn't have a lot of polygons in it, and then we're going to extract the maps and see how we can displace the low res of this complexity back into the high res. And we're also going to learn how to automatically create UVs for complex meshes like this. And so it's cooking right now, and it's gonna take some time because this is a 3 million polygons. And you can see already, now it's done, you can see already it's done a great job by trying to keep the mesh as close as possible, and this is a very good result. Now it's going to be really high for in-games, and what I generally tend to do is I keep this because the process is heavy. I don't want to change that value. I copy that and then run another poly reduce on top of that, and this way it's going to be much faster, and the result is not going to be far different than changing this back to 1. Let's say I do another 10% here. It's as if I've done 1 here. And you can see it's much faster now. And this is something that we can use for in-games directly. Cool. So this is one way. And then let's take a look at at this guy. This guy is going to be a little bit heavier. So what I'm going to do is I'm going to delete some points and delete certain parts of the mesh, and just work on that. Cool. So I've increased the primary setting for this is the edge length, and that's what I prefer to use. Whenever I use this node, that's the method I use. The other one tends to not. There's two methods. There is fixed length and adaptive. Adaptive will try to be smart and analyze the mesh and place the polygons only when it thinks it's necessary, but the result is I'm never satisfied with the result of the adaptive. So if I use this node, it's most likely with the target length. And I personally use this to just create a low-res mesh that I'm not going to use in production, just for preview. This is very useful for that. And you can get a very low-res version, and it's much faster than pretty much all the other workflows. So let's try 10. The higher the number, the less polygons you're going to get. Again, it's not the same as polyreduce where you can tell it percentages or specific numbers. This is going to be based on the mesh density. And so far it's not going further. I think that's the minimum can go to. So we'll do another remesh on top of this as well. Yeah, so iteration helped, but let's do another process. And again, this method I only use to create a low-res mesh. So with when you guys go through the assets and to export the low-res for previewing, I'll try to use this node. You can see now this is very cheap way of generating a low res. It's trying to keep details for sure, and I think that's going to be very useful. And this is not what we're going to use for the UV. We're going to use the VDB, which is the best. So with the VDB, there's a few more things, few requirements. And the first one is the mesh needs to be enclosed. You cannot have any open surfaces. And I'm actually going to change. Okay, that's fine. So let's take a look. And luckily with the stuff we're doing, because everything is done through volumes, it means there is no cavity. There is no opening in this mesh. There could be something, but it's not going to be a huge gap. And whenever you have a mesh that you receive, you may have to do extra processing on that to basically cap all the openings. And the easiest way to do this, let me show you a quick way. So let's say this is the grid and we have an opening there. What I generally do is I would group the open edges like this, and then change this to edges. You can see now group the exterior and the interior. Now obviously this would be a volume, so let me make that a volume actually. Let's extrude this. And let's delete some polygons. And let's show the wireframe. Cool, so now we have that opening. And we can use the group feature to find that. And then the polycap in Houdini 16 is really good. So it knows how to generate the surface much better than the previous one. And I would triangulate them. So this is the easiest way to find the openings and polycap them. Okay, so let's go back. And we know that our mesh is perfectly fine. So I'm going to just use a VDB from Polygon. Pardon me. I'm going to lower this to 0.02. The lower this value, the more details you get. And then all I'm going to do is put down a VDB convert and convert this back into a mesh. And the great thing about this is that it's going to generate only quad surfaces, which is great for everything, for games, for VFX. It's a well balanced mesh. It's uniform and it has only quads. And this is what we're going to be using for UVing. So we're going to UV this mesh, and then we're going to bake the texture and apply it back to get the high-res surface with the UV on it. So now we're going to learn how to create UVs for this. And the easiest way that we can use is to find a good edge that travels through the mesh and then use that with a UV pelt or a UV unwarp to unwarp the mesh. And I'm going to use the edge selection, and there is a very handy feature here. If I select an edge and hit Shift A and keep holding that, it's going to use the find closest path to the next point. So I'm going to keep following this until I get the edge that I like that travels through the entire mesh. And this is a very quick process. And I'm going to keep doing that. Continue all the way. And I want to select this guy. And now I'm going to type in group, and then we should be able to group the edges. Cool. So let's call this edge selection. And let's use a UV pelt. And with the UV pelt, I'm going to give it that selection. And let's take a look at the UVs. Cool. So now we have that something at the center. I'm going to change it to the barycentric mode, which gives the best results so far. I'm going to increase this to 250. Let's try 1000. And let's increase the boundary springiness. Cool. So we're done. That's it. That's all we have to do to create the UVs for a mesh like this. So let's take a look at the UV quick shade. Perfectly fine. And this is going to be very easy to work with because you can see there is not so much distortion. There is a little bit here, but it should be fine. And what we can do is we can also run a UV smooth on top of it to relax it a little bit more. So let's change it to 100, change the quality. Yeah, and that just helps a bit. And you can see how easy it is. And now the trick is to transfer this to the high res. Okay, and that's going to basically require the baking process, which we're going to be start doing in the next video. But before I move on, I wanted to show a different approach for creating this. Creating the path selection, I want to make it dynamic. And what I'm going to do is I'm going to create a group with all the points first. Okay, so I'm going to select not that, this guy. So I want the low res mesh, and I want to group all the points. I'm going to call this group 3, that's fine. And I need to create an attribute, and I need to store the ID, and I'll explain why when we get to it. So the ID is going to be the point number, basically. Cool. And the next thing I'm going to do is I'm going to select a couple of points at the top and a couple more points at the bottom. So I'm going to select one here, one here, one here. And I'm going to group this and call it top. I'm going to select a few more and call it bottom. And now what we're going to do is we're going to use a node called find shortest path. That's going to require two groups, the start and end. So the start point is going to be the top, and the bottom is going to be, the end point is going to be the bottom. And I'm going to see the result. And boom, we have selection now. But look at how it's merging in this path, which is totally fine from each. So let me change this. You can decide how the points will behave. I'm going to set it to from any start to any end point. And it depends on the path that you have. It will try and find the most suited one and keep that. Sometimes it will result in providing 4 different paths, and you have to just select the one that you need and then delete everything else. And this is a little bit more dynamic. All we have to do is select a couple of points at the top, select a couple of points at the bottom, like 4 on each section, and then use that, and this will automatically give us a path between those 2 targets instead of having to auto select that. And we need a way to know what this path, where this path came from. And the point number attribute that we need to specify is the ID instead of org PT, and we've already created the ID. And what we can do is we can create a color here. So we can give this guy a color, and we can give the original mesh a different color. So I'm going to copy this. Okay, and I want to copy that information back to the mesh. So attribute copy, and I want to copy, let's see, from this into this, and I want to copy CD and match by ID. Okay, and now we should see, let's see, yep, it should work. So let's see why it's not doing. Okay, it looks like, yeah, so I need to use this mesh because the ID attribute doesn't exist here. So let's use this guy. And now we should be able to see that group. Boom. There it is. Now how do we select that? Well, it's very easy. We're going to use the group expression. And in this group, we're going to tell it if the color, the red color, for example, is higher than 0.1, select the points. I just need the points there. And we need to change this to an edge group, and the easiest way to do that is using a group promote. So promote, let's take a look. So group promote, we want to promote, let's give it a name, edge as points, and we want to promote that. Let's rename it edges. And in the promotion, we're going to convert it from point to edges, and see now it's selecting everything else, and we need to keep only elements in there. Include only elements contained in original group. That's very long. So it gives us the selection that we need, and then we simply use that with with a UV palette. Let's connect that, and let's select the group. Let's take a look at the result that we have, and there we have a perfect UV that we can use to generate the displacement map, and we're going to be doing that in the next video. So this is one of the easiest way in Houdini. We're going to talk about more setups when we needed them. Again, for this section, we're going to be using primarily the triplanar and using high-res meshes in Arnold, but I wanted to cover this and explain the UV creation process. So we'll start extracting displacement in the next video. On this, we have the low-res mesh. I'm going to create a null and call this out low-res. And let's create another one for the high-res mesh, which is this guy here. So out high-res, and let's object merge this. And by the way, we're supposed to be doing this in the actual original file of the asset, but I didn't want to overcomplicate things. But you guys should. Whenever you do processing on the asset, you should use the pipeline tools and open the correct scene files for this. So let's import the high-res and low-res. And I think, yeah, this feels a little bit too heavy, but let's see. Let's copy this guy. I'm gonna turn off cooking. I'm gonna change the viewport so it doesn't compute anything, and I'm gonna drag this here, and let's copy these guys and call this let's leave it, that's fine. I'm gonna call this low res, and it's good, and let's create another one, high res. Let's paste it in there. Cool, so we have the two geos. Let's create a camera. Let's turn on cooking. It's loading. Okay, cool. And let's go to the out context, create a bake texture. I'm gonna set the resolution to 4K this time, and the low res version is this, the high res is this, and I need displacement. Target, I'm gonna change it to TIFF. Actually, let's change it to RAT because this is what Houdini likes. And I'm gonna change it to trace closest. And under rendering, I'm just gonna increase the pixel samples because this is a very a complex mesh. And I'm gonna increase the bake samples to 32. I'm gonna hit render and come back when it's done. Okay, so now that the bake is done, I have the displacement map, and what I'm going to do is I'm going to subdivide the low res twice or 3 times as much as I can, and then we're going to displace it. And again, doing this, we're going to keep the UVs and all the attributes that we have on the low res mesh. So how much? Let's try one more time. It's computing. It's coming. It's coming. Cool. So how much do we have now? Almost 2 million. Let's create a point VOP. And here I want to create this from scratch just to make sure that you guys understand the process. We need to import the UV coordinate, which is a vertex. So I created a vertex, import vertex attribute. And then, let's see, and then we need to vector to float that. And color map. And let's connect. Let's add another vector to float. I just need the one channel from this because it's a displacement map. And displace along vector. Displace along normal. P. This is the amount. And this is the original mesh. And let's connect the map that we have. Cool. So let's take a look. We should see some displacement going. Cool. And let's expose the map. And let's use the one we just rendered. So it's going to be this. And I did not add the padding option. And this is the displaced mesh. Now you can see we have one error, one issue here, and that's called nan. And the nan is basically an infinite value or a spike that we get on the edges of the boundaries of the sim. Now let me open the file. I want to see if I can locate that. And we should see here, we should be able to see it. So it's probably this, you see it, there's a change there. If there is a negative value, we're not going to be able to see it unless we invert the image, which I don't think we can do here. Yeah, we cannot invert it here. You know what? I'm curious now. I want to see the value. I'm going to switch to image, create an image network, and let's import that file. gain it up. What's happening? Sorry, I'm in the render view. Yeah. Cool. Let's set this to 1, 1. And let's gain the image. Cool. And let's invert it back. Let's invert it, sorry. Take a look. Let's gain it down. Yeah, and I'm seeing something. So that could be the spikes. The spike. It's hard to tell exactly, but you can see there was one issue there with the map. It may not necessarily be that though. Let's try. Yeah, we can spend time and try to figure it out here, but I know how to fix it. So let's not make a problem out of this, and let's go back. Let's dive inside. So the reason is we're getting that none, which is basically a spike in the pixel of the displacement, and the easiest way to fix it is by clamping the values. Yep. So let's clamp that, and you can see now we're clamping to 0, and we're just leaving the stuff that's being pushed out. We can do the inverse. We can set this to 0 and then set this to -1. And this is anything that is pushing in the surface. And you can see that's where the spike is. It's in the negative range. And let's just tune this so that we can, actually let's set this back to 1. So let's tune this value, it was -1, till we get rid of that, because it's different than anything else. So even if we trim it here, we should be safe. So let's try 0.5. And we have to be very careful. See, nothing is changing, and that's good. So 0.2, cool. So we killed something, but nothing else changed. 0.1, we still have something here. So let's try even going lower. I think we're gonna start hitting the range of the image. Yeah. So at that range, we're starting to lose details. See here, and unfortunately, that's the best we can do. So let's try 0.1 here. Yeah, that's the best. This area is probably has a lot of curvature, and this is the best we can get out of this result. Cool. So this is the low res displaced, and now we have this awesome UV that we can use. Let's browse the map. Cool. So now we have the high-res version textured and perfectly ready to use. Now you can send this to any package you want, and you shouldn't have any issues working with this. Now what else? Now we can still take this further and try to capture some more details from that low res into the high res, but you can see, let me transform this and put them side by side. Let's do just one. Okay, so that's the original, and this is the low res subdivided and displaced. And let's put them side by side and see. Okay, so that, let me untemplate this guy, hide everything. Okay, cool. So you can see side by side, we're not seeing any difference. We're not seeing any major difference, let's say. Maybe a little bit here, but again, if we look at where we started this from, I think it's great to be able to get this. And this is exactly how the renderer is going to behave. It's going to subdivide the mesh and push the polygons. So whatever we've done this in the sub level, we have to do that in the render. And I'm not gonna start looking into that yet, because we have a lot to cover already with the Arnold. I think this is pretty much it for the UV creation and baking part. And now we're going to start looking at rendering and shading these assets and how to use Arnold. In this video, we're going to learn about LUTs and how they work and what's the advantage of having a LUT in general and how to use them in Houdini and how to set up the ACES workflow. Now, I have a render here. I have a scene here with a skylight. I only have a sky dome with an HDR, and I have a sunlight, and I just turned it off, so it's just the skylight right now. And I'm going to increase, try to tweak it so that we see a little bit more information from this HDR. Okay, so I've increased it to 40, and let's see what we get. And look, you can see now we're getting a lot more information from the HDR, but everything is blown out. Everything is super white. And look at how these fall-offs are. We're getting very clamped images, and the result, if this was correct, the illumination result from this should be much higher. We should be getting a lot more information back, a lot more indirect illumination from that. But we're not getting this. And if we tune it down, you can see as soon as we hit white, it becomes white. It becomes super washed out. And this is a big problem. Let's introduce the sunlight. It's probably too high, so let's set it to 6. Now I'm trying to add this a sunlight back to try to get some more information into the scene. But so far, everything is getting clamped at 1. We are not able to see anything above, which is basically what everyone is doing when they use the render by default or they don't have a LUT workflow. And the main reason movies look much more realistic by default is because they have these LUTs workflow. They have a LUT for every movie, and every render you do generally render in the same color space as the movie was shot. So for example, there is a very common format they use in cinema. It's the S-Log, and the actual camera capture, the image range goes from 0 to 54, and when you look at the raw image, it's not interesting. It's super flat. There is no contrast. There is nothing. But once you apply the LUT to it, it looks way more better than anything you've probably seen. And that's why they look much more realistic, either the render or the camera itself, because they capture a lot more information than just a range of 0 to 1. They're not limited to that. And with this sRGB workflow, we're rendering in linear space and then looking at the result using a 2.2 gamma, but we're limited to white. This is as high as we can get. That's it. If we surpass this level, we're not going to get anything interesting. And this is not enough for us. This range is very limiting. It doesn't help with the physically based render, because if I expose this, if we were to shoot an environment, a real photo, if this area looks like this environment will look much brighter because of that intensity, but it does not here. So there is something wrong. There is something broken, and this, what we're going to be doing is what will take your render to the next level. There is nothing else. If this doesn't make your render better, then there is something else that you need to revisit. And by just having this LUT workflow, once you get used to it, there is no way you're going to render without it at all. Your render will look, once you get used to it, your render looks much better by default. And everything you saw in the workshop, every single image here. Let me pull up the link. Every one of these guys is raw render. Every one of them, including this, which in this kind of stuff is basically impossible to get. if you were in a normal workflow, all these images are done, are raw renders. This one too. Everything you see here, there is no compositing involved at all. And it was done using the ACES workflow, which is the LUT. Now let me continue tweaking this. Let's go back. I'm gonna snapshot this. Actually, I'm not gonna snapshot. I'm gonna take a picture, because if we take a snapshot, it's taking into account the LUT. So I'm gonna call this no LUT. And I'm going to turn on the LUT and retweak with this. And I'm going, we can load a LUT using this. So load the LUT, and this is what we're going to be using. And I will explain where these came from and how to install the workflow. And you can see by just doing that, something changed already. See, this is the original one, and this is with the LUT applied. But now we don't need this stupid 2.2 gamma correction. We don't want that. We're going to set this back to 1. And this is what the render looks like with the LUT. Now look at how much information we have. This is without the LUT. Look at how much information we're getting clamped in there. And then once I turn on the LUT, look at how nice these shadows are and these highlights. And this is much more realistic. Now look at the difference, the illumination coming from this wall. It feels much more realistic, because now if I look at this value, see it's 1. Let's gain this image. Okay, let's go to, it's not very high. So let me change few values in the lights. I'm gonna leave these guys here. I'm gonna load this for LUT, both of them. And for LUT. And let's hit render again. Cool. So these lights are much brighter, and let me tune them down. So let me set this to 100 and 40. And you will notice quickly that we need to, once you start using this workflow, you will see that you need to increase the luminance much higher. Now I'm just using the sky dome, and let's increase this to a stronger value. You can see now we have much better information here. Let me crop it to this region. Nice. Now look at how awesome this transition is. We're not getting any clamps anymore, and look at the value, it's 80. And look at the indirect bounce from this, it's much more realistic. And let's go higher. Let's go 80. Now this is a lot more higher, and we're still not getting white yet. Look at the values. A 24 here, and we have 24 here, and we're seeing information. Look at this. We're seeing information there, and this is basically the key to getting realistic renders. We need to render between 0 to 100, let's say 0 to 20 and above. And I set this to 200, probably too high. And let's introduce the sun back. I want to introduce this guy back in. And look at this. Look at how awesome the highlights are. We're not clamping anymore. Oh man, I can't believe the sRGB workflow. Look at this. Now with this, we're gonna get a lot more information in the highlights, because it's not gonna clamp. It's gonna look way more realistic. We can push the values, and we're gonna get much nicer fall-offs in general. And this is not color correction. This is very different than color correction. You will not get this if you take the image in sRGB and try to do it, try to color correct it. You will never get the same information. We're rendering in a different space that is not sRGB right now, and it's the ACES workflow. And what this ACES attempt is, there is many different LUTs. You can find them online. The ACES workflow is the attempt to create a standardized color space where everything will look the same using the same monitor. And they have different simulators for different camera, and the default one, ACES CG, is great already. You don't have to do any further tweaking. You can see we're getting also a lot more contrast in the shadows. Okay, in the mid-tone, in the black tone, we're getting nicer saturation. It looks much nicer here. And now the colors will have to be tweaked accordingly, because there is also a shift where the blue will not look exactly the same. The blue that you will see here will not be exactly the same. So you have to tweak the values to give you what you want in the viewer. And let me turn this off again, and let's take a look. And this is without the LUT, and this is how it would look like if we were using sRGB. Let me gain it down, and this is these are the value. Let me set this to 2.2. This is the result. Okay, and you can see how flat it is. Actually, let me capture this. And let me open the image. Okay, so this is the capture. And let's put back the LUT. And let's set this to 1. And look at the difference. There is nothing, I cannot stress enough how important this is. Now let me show you a cleaner version with just high-res settings. And this is the raw image. You can see here how nice these glows are. You're getting a lot of interesting illumination. It feels much more realistic because the light is behaving much more, it's behaving in a more realistic manner, because the value that we're seeing now is actually what's being used in the render. And we're gonna get a lot more highlights. You can see there's just tons of information, and this is one quick example. And let me put them side by side. This is the sRGB and this is the LUT workflow. Okay, now in the next video we're going to look at how to install the ACES workflow. I was using it through the LUT here, but there's actually a open OCIO profile, which if I turn on, it gives me this ACES workflow, and you can view the image under different format. I'm still not sure what this is for, but you can simulate different cameras and different color spaces. I use the sRGB, which so far gives me the best result, and you can look at the raw image as well if you'd like to, and see now how we're rendering between 0 to 20 or something like that, and we're able to see it nicely. So we can squeeze way more information out of the render. Actually, let me do one last test. I'm going to increase this to 600. I want to see the cap. So we're still seeing there's a little bit of fall off there, and see the values. And let me gain it down just a bit. See, we can see a lot more information, and this is this is what you need to use. This is the secret to photorealistic render. Even if you're not, I mean, I didn't do anything with this render. It's just a skylight and a sun, and I turned off GI basically, and I have the some water surface here to capture more highlights and more reflection. There's no secret to it. I hope this makes sense. I'm sure once you guys get used to it, you will start to understand what's happening. I'll try to find some more resources about it, but it's basically the way to go. So in this video, I wanted to talk about the ACES workflow and the Opencolor IO pipeline. So if you go under the github.com/imageworks, this is a Sony open source project where they are hoping to create a unified color correction pipeline and for VFX and basically any CG related rendering. So if you go under sorry, not Opencolor IO, Opencolor IO-config, and under here you will see that there is this ACES workflow. and the latest version is 1.0.3, and this is the one we need. Now you can clone and download the whole package, and we'll include everything, and then all you have to do is extract these folders. So in this case, I've extracted them here. This is the package, and then once you extract it, you'll see it has all these folders, which is basically this, except I deleted these guys. So the one we're interested in is the 1.0.3, and inside this folder there is a config.ocio file, and this is an amazing thing for VFX in general. This this config file defines a variety of things that solves a lot of issues, and by just exporting one environment variable, all the other packages, mplay, Houdini, Arnold, I'm not so sure how much Mantra has this, I don't think they do, but mplay supports it, RenderView supports it, Arnold supports it, and then Nuke supports it, and Natron and various other packages supports it as well. So all you have to do is copy the path to this file, not the path where it lives, and then export an environment variable called OCIO that points to that file. And you're done. Now once you do that and restart Houdini, under the render view you should see this ACES workflow. You should see this option here. And the default is fine. We're going to be primarily using this. We're not going to change anything. And then the other thing that you will notice is when you open mplay with Houdini 16, the latest version, not the previous one. You have to have Houdini 16. And come on. Yeah, here I have this already. So you see here I have the Opencolor IO option, and I can turn it off, and or I can enable it and say raw, and this will show me the image in linear space, the original render in linear space. If I want to turn this off, I have to disable the Opencolor IO option and then change it to gamma. And now we're back to default. This is how the render looks like in an sRGB space, the same render. And look at these guys. Now to turn it back on, right click and say Opencolor IO profile, and then make sure enable Opencolor IO profile is turned on. And this is set to sRGB. Look how beautiful that is. Now these are the primary options, and if we go under Arnold, I have made a couple of changes to the UI because it's too much dark gray for me. And so if we go here, I'm gonna hit tab and type in Arnold. Now Arnold has great support for OpenImageIO, and they're still working on it. The reason I'm calling it OpenImageIO because that's what the project is, and then part of it is the ACES workflow. And then here, if we go under Properties System, there's this option for rendering. And what this is going to do is when you have values, let's say a shading value, for example, a refraction or absorption, the values that you need to put in, especially with hair, the melanin value for the hair, for example, the value that you're going to put in the shader needs to go through a ACES workflow multiplication to give you the right value, so that what you see is what you get in the render. And to get that working properly, if you click here, you'll see all the options available because of that OCIO workflow that we exported. And the one we're interested in is ACES CG. I generally set this to both of them, and then that will also be used. No, it won't be used. Yeah, it will be used in the texture conversion as well. So when we create a shader, now create an image. See, it says auto color space here. It will use the settings for from OpenImageIO to do the texture conversion from linear into the OCIO, into the ACES CG workspace, and that will give you the correct texture. So everything is set up. You don't have to worry about anything. And then when we start doing some renders, we'll get to the we'll learn how to view them in Nuke, and then how to save them out as well, because I think that you guys will need this at some point. And then what else? I think that's pretty much it. The only option needed is you download this and then export the OCIO environment variable that points to this file. Now, when we go to the render view, there is also this option here. But if we turn it off and say load bake, we can actually load the bake file, which is basically getting loaded, but the system takes care of that. So if you go under the ASYS 103, under baked, under Houdini, this is all the LUTs that we need. So we can load one from there directly, and that should give us the same result. And the one we're interested in is sRGB for ASYS CG Houdini, and that will be the same as the one we were just loading. In this video, I wanted to explain the new features of Arnold 5 and what has changed since the previous version. So I have a scene here with a grid and a sphere, and I just created a new Arnold node. And let's go over the menu and show you what changed. So there is a new thing here called transmission, and previously there was two options, reflection and refraction, and there is this indirect specular blur, which I'm not so sure what its advantage is, but I believe it can be used to reduce the caustic noise, but I haven't seen any difference or any documentation about it. It could be a new feature that it's not in the docs yet, so we're gonna ignore that for the time being. And then these are the same. The main change is the transmission, and then under depth, under ray depth, there is also transmission, and previously there is reflection and refraction, and now everything is treated the same. Everything else is the same. I mean, there is a lot that changed, but the UI and the option looks the same. There's this new option here called indirect sample clamp. It's set to 10. We're going to change that to 100 because we're going to be using a much bigger range than 0 to 10, so make sure it doesn't clamp. And then there is a new thing with the AUV, and this is something they started with the volumes, where they added light AUVs for the volume, and now you can basically declare give any light a name or a group, and then say RGBA light group, the name of the group, of course. Let's say we call the environment EMV, and then RGBA sun. We'll do that, and we're gonna get two separate beauty passes for these guys. There is a new options as well to create specific AUV. Let's say you want the indirect illumination of a specific light, you can get that as well. Let's say you want the indirect the direct specular, the direct hit of the light into a separate AV, you can get that as well. Same for the subsurface and all of them. That's supported now, but we'll cover that when we get there. And let's see now, the other main changes is some are in the light and the majority is in the shader. So let's talk about the lights. Pretty much the same, except this new option here, which was there already when for the volumes, but it was not supported for the surfaces, and now it's supported on both. The light rig that I have uses that, has the AUV named. I actually remember to change the location of the HDR texture. Cool. And so we have our lights. There is a new option for portal lights in the Sky Dome to help with solving the noise problems for interior scenes. We're not going to be using that, but it is there. There is this option here to change the result of the environment lighting. Right now it's considered as a direct ray, and that's where I will keep it. You can decide to put that result in the indirect lighting if you want to. So you have the first bounce is just the lights, and then the indirect you will get the Sky Dome, which I'm not going to do. I want to leave it in here because I prefer to use the AUV. And then let me try to remember. Yeah, I think that's pretty much it for the lights. And then in the shader is where the majority of the stuff. So they have this new shader called Standard Surface. And let me create the old one. Did they delete it? No, it's called Standard. So this is the old one. And I don't recommend using it because it doesn't have, it's not up to date with Arnold 5. 100% doesn't support AVs and still uses reflection and refraction, and that's deprecated now. So the new one is basically similar to what, if you guys are familiar with the alt shaders by Anders Langland. It's very simple. There is diffuse component, there is specular, and you have transmission. So these are the primary three, and then on top of that you can add subsurface, and you also have a secondary coat by default. There's also option for iridescence to create the oily specular, and then the bump is all now is plugged through the shader. Previously it was connected to the final shading group or the final out, so there used to be a bump here, and by doing this, by having it in the BRDF or BSDF, we can layer multiple ones, each have a different bump. So you can have a layer with a superfine bump and then another specular or a coat on top of it that doesn't have the bump to create the more complex layering effect. And so that's basically here. And then what else? This SSS is a single layer scatter, and it's different than the skin shader. And then there is also the transmission now has a depth option, and this basically simulates a single scatter shader. And what else? I think this is primarily the majority. There's also a metalness component, but we're not going to be using that at the moment. And that's pretty much it for everything. Let me assign this shader to these guys. And let's see. And let's do some render. Cool. Switch this to Arnold 1, and now we have to make sure that our LUT is set up. It's working. Cool. You can see already it looks really nice. And without the LUT, we won't be getting this this contrast in the image. So everything looks cool, and let's try and change a few things within the shader. Let's try the secondary coat, and it has a different roughness, so you can have the primary one be very rough, and then the secondary one have less roughness, so you can layer them up. And it has a different Fresnel, so you can control that. I think that covers the majority of the changes. I mean, there's a lot of changes, but they're all under the hood. It's much faster and much easier to get cleaner image, so you don't need to put super high res samples in most of the cases. And then we're going to start shading our first element. So now we're going to start shading our assets, and the first one we're going to start with is the standing cliff. So let me go and delete this guy, and we have the setup ready for us to use. So let me switch back, and I'm gonna delete these two guys, and we need this geometry here. Now, because we've exported this, we can easily use the Arnold procedural, and let's see. So the asset is called Standing Cliff and version 1, and now we should have the procedural ready for us to use. And we call this Standing Cliff proc, and let's assign the shader. And the reason I wanted this is because I don't want to export the geometry every time. And let's assign the shader. And let's change the camera. I like to change it so that it fits better the proportion of this asset. And let's not use cam 1, let's use the render cam. And let's change it to 900 by 800 by 900. Okay, cool. And I wanted to talk about the light rig now. So with this ACES workflow, we're going to be rendering in a much wider range instead of 0 to 1. And the light intensity needs to go way, way higher. And if we do the look dev under this under this ACES workflow, we're not going to be able to use these assets on a different color space. If you put them in sRGB space and use dim lights relatively to that workspace, the colors are going to look much, much dimmer. And we're going to be tweaking everything to look correct in this workflow. We're not going to care about anything else. And there's a whole process for creating a balanced light rig where you go shoot some HDRs and then take references for what the diffuse ball and the reflection ball looks like, and then try to match those as close as possible. We're not going to do that. We have a full CG environment and we want to go with that. And as long as we do the look dev and shading under a neutral light rig, it's not really neutral. It has to be, we need to test it under a white light, but as long as we make it look good in this light rig, which pretty much has some white in it, it's not fully desaturated, we're going to be fine. But again, whatever we're going to be doing here is not going to work in a different, it's not going to look correct in a different workspace, so keep that in mind. And in terms of light rig, it doesn't matter if our light rig is scientifically or physically correct, as long as it gives us the visual that we need and use it on all the assets, we're gonna have something that works. And then later, when we change the light, the light rig to a nighttime, we're going to have to tweak the lights to make the assets look good. We can go further and create a second light rig with multiple point lights, trying to replicate what a nighttime scene would look like with candles and things like that, but we're not gonna go into that level yet. We're gonna use this light rig and hopefully get everything to look as good as possible. We may have to make a few tweaks to it. Actually, probably have to change this to a lower number. Let me check the latest version I have. Yeah, so I need to change this to 4 and 5, and then the sky dome to 1.6, which is more realistic. And let me check. Okay, cool. So I think we're fine there. Yeah, we may have to do some minor tweaks. And this is 23, so we may have to, yeah, let's go to this frame just to match. Actually, let's change this to match the scene I have, but it's not a big deal. And then yeah, we're going to start doing the shading. So let's go to the turntable. Let's use the APR base. This is fine. Let's change the camera to the render cam, and instead of this, we're going to use the cliff procedural. And then for the candidate light, I want to always explicitly add them, because the reason I want to do this is if I later add lights that I don't want them to come in and change my scene, I don't want to inherit them. Same for these. I always do explicit assignment. And let's change this to APR base and hit render. Let's create two AUVs, RGB ANV and RGB A sun. Okay, now we don't have any shader, any look depth, so everything is fine. And let's start with assigning some textures. Now I have went through and converted the image file I'm going to use to TX files to avoid the conversion. I'm going to show you the textures that I'm going to be using for this one. So I have this guy here, and then I have, so this is one map, and then let's see, Brock, this guy, this one to add extra displacement, it's called rocks, and then a displacement file to add more details as well, that maps to the texture itself, and then specular, and all of these converted to TX, so Arnold doesn't have to do any conversion. And this is a specular file that we can also use for the bump. Cool. So let's start by reading the first one, and I don't have any UVs on the mesh. Probably, yeah, I don't think there is no UVs on the mesh. And what I'm going to be using is something called triplanar. So let's create that. And what this does is it creates a UV coordinate based on the normals of the mesh. And it's very handy, especially with the type of textures that we're going to be using. I think it's gonna work just fine. And I load in the first file. Now these textures, we did the look depth for them on a different workspace, on an sRGB workspace, which is fine. And what we have to do is I see it's already trying to render that, which is great. Now let me turn off the diffuse, the reflection, and this one too. And this is the texture assigned to the geometry now, and you can see it's working perfectly fine. Now the thing is, we have to fudge a little bit the textures and do a color correction on them, because the exposure is not very well suited for this environment. We also have to basically tweak the gamma a little bit for the textures, the saturation, just to get the colors that we need here. This part could be improved a little bit, but with the separation that we had between the procedural texture creation, this is the easiest way for us to dynamically work on the texture. So I'm going to increase the brightness of the image here to get more diffuse. Let's take a look at the sun and EMV. Cool. And let's make sure we're getting some GI in the scene. I know the setting it is on. Yeah, cool. Okay, let's increase this to 4, and let's go back. And I wanted to show one option, which actually I'm gonna turn on. The sky dome now has a feature to show the map on the background, and we can actually have that on if we want to. So we'll leave it there. And let's go back to shop. And let's continue tweaking. I have previous values. I'm gonna add a little bit more gamma to add more contrast to the image. I'm going to add a little bit more saturation, and let's increase the contrast as well. Cool. And we can change the texture here if we want to directly add multipliers. Obviously, you can see once we start changing the colors, we have to. The result is not something that we would expect. For example, when I go here, the image is completely black, and the reason for that is because the color space, the LUT is crushing that black area. So we have to lift everything up to be in the range where it's visible in this LUT. So for example, you can see here we're getting a lot more contrast. And let me show you what this looks like with an sRGB color space. See, it's basically this, but with the LUT, we're getting something completely different. And we're going to tweak it to look as good as possible with this. Okay, cool. So let's tune this back down. Let's turn off the color and let's continue. So what I'd like to do next is I want to tweak the texture tiling. So I'm going to change this to 333. I'm going to change instead of the coordinate space object to world space. And I want to use world, especially that I know the texture is not something the object is not something I'm going to be animating. And by doing this, when we instance them, each instance will receive a different world coordinate, and that will generate different triplanar. And we're going to use noise as well to help mix and vary the textures between the instances. Now I'm going to copy this and make another one with a much bigger size. Let me show you guys this. So now we have a much bigger pattern. You can see the texture. And I want to mix between these two guys. And I'm going to use an Arnold noise. It's very simple. I'm going to set it to world. And let's mix these two guys. This is the first one, the second one, and this is my mix. And with the noise, I like to add a clamp because it will give us negative value between -1 and 1. And with the clamp, we're safe to clamp the range. And I don't want to go higher than 1 because that will start making one texture brighter than the other. And you can see now we're getting already a lot more interesting mixing between the patterns. And let's increase this. I'm gonna change it to 3, 3, and 100. And why I did let's put it back. Let me gain this up to show you guys the texture a bit more. And the reason I changed this is because I want to get some kind of stripes along the y-axis. So let me start increasing this, and let's focus on this region. You can see how it's styling along that axis, and if we set it to 100, we'll get a lot more details here. And you can see it now. We're getting a lot more variation. Cool. I feel like oh, okay, yeah. Cool, so let's continue. And I want to make the noise a little bit stronger to see these tiles a bit more. I'm going to increase the amplitude of the noise, and that will bring the textures up. It will make the noise much more clear. You can see it here. And one thing I'd like to do is, if we go to the out context, I'm actually going to change the resolution to 1600 by 1800. Because this is a very sensitive asset, and we need to be looking at the super fine details. And I'm going to change the system bucket size to 32, so I can focus on a small region and still get faster preview. Okay, let's go back to shop, and let's play with the noise a little bit more. Let's add some distortion. I will show you guys what the noise looks like, and I want to add a little bit more octaves to it. And let's take a look at the actual noise. So this is what the noise itself looks like, and that is being used to drive between the two textures. Cool. Let's continue. Now what I'd like to do is, let me think. Let's add something else. So what I'd like to do is I want to add a little bit of curvature shading to capture more details from this rock. And I'm going to use a curvature shader, which comes by default with Arnold, and I'm going to connect it to show you guys how it works. Cool, so you can see now we're getting a lot of interesting details, and I'm going to change this output to both. Instead of convex or concave, I'm going to tell it to output both, and that will use the red and the green for the concave and convex. And I'm going to increase the details, the samples, and I'm going to lower the radius, and that will bring up a lot more details. So the smaller the search radius, the finer the details it's going to capture. But sometimes it can get really noisy, so we have to be very careful with these. Something like this could also be very helpful. Let's set this to 0.1. And let's control the spread as well. Cool. So something like that, just to bring up a few details here and there. Maybe a little bit more. Yeah, something like this. And what we can do now is, it's a little bit uniform. Let me set it back. What we can do is we can take another noise. I'm going to set it to 3, and I'm going to put down a range, and let's see which one controls the radius. So this guy can make the line thicker and smaller. So, and a range of 0.5 to 0.2 is good. So 0.2 and 0.05. Okay, now I want to use a noise map and remap it in that range. I'm going to use that in the radius. And what this will allow me to do is I'm going to vary how the curvature. I'm going to basically add more breakups to this line. You can see how smooth it is. I'm going to add more breakups to it. Let's increase this to 3. Let's lower it a bit down, and let's increase the noise. Let's go a bit higher. And if we want to see the map at any point, we can simply connect the surface or anything we want, and we'll see the noise. Now it looks like we have a lot of white values. Let's increase the noise to 60. Let's lower the distortion. And I want to see more gain. Okay, so I'm not getting a lot of breakups, and what I like to do is I'm going to copy this. I'm going to set these guys to 200, 200, 200. And let's view this noise. And I'm going to multiply both of them. And now we have more breakups. You can see already maybe 180, 80. Cool. And let's add maybe some distortion. You can see now we have more breakups. And let's use the red channel, and you see how that affects the curvature. Okay, cool. So now we have more breakups, and let's increase this to 0.2. Okay, and I'm going to use that to drive something. And I'm going to use this information here, which probably we need to tweak a little bit more. Let's increase the multiplier, because where we're going to use it, it needs to be much brighter. And remember, these values are in the ASYS workflow. So the appearance is not necessarily what they are. For example, this is 1, and that's what the shader will use. And I want to use this information to vary the color of the diffuse. I want to vary this guy. Okay, so what I'm going to do, just look at the RGB. what I'm going to do is I'm going to create a color correction node, take this result, and let's change a few things. Let's increase the gamma. Let's desaturate it a little bit more. And we'll continue playing with it to get some more interesting details. And now I'm gonna use another mix to mix between the original and this version using this guy. I want to use just one channel. And let's take a look at the result here. So now it's not very visible, and it's cool. So now it's much more visible. And this is what we can do. We can change the texture on those edges to anything we want. And that will add a lot more dynamics to the shader. You can see already it's working much nicer. And let's connect this result to the diffuse, and let's take a look and see what we get. Nice. You can see now we have a lot more interesting details. And let's do a full render. And remember, we don't have any bumps, we don't have any specular, just diffuse. And maybe it's a little bit too strong, but we'll leave it at that. You guys get the idea. I'm gonna increase the diffuse roughness because a rock generally has a lot of fine details, and that causes the micro facets to make the surface look a little bit flat, and that's what the diffuse is for. And I'm going to set this to 1 for the time being. Again, this is not physically super accurate, but as long as it gives us what we need, I'm not going to worry too much about that. And let's take a look at the sunlight separately from the environment. Cool. Okay. We're getting there. I feel like there is a reflection pass, but it's not. I don't think there is. Also, there is a red and green channel in the curvature shader for the concave and convex. And you guys should play with both and see which one works better. So let's try the green. Okay, works. It's creating more details. There is more change in the cavities now, which is cool, but I don't think this is what we need. And I like to use both of them. So what I'm going to do, I'm going to change this to red, and then I'm going to make another one. And this time I'm going to take the final result and put another color correction. And let's region this. And this time I'm going to color correct this. Let's pause this guy. Okay, we have this. Let's mix between the original and the new. Sorry. Using the green. And let's connect this to the color. And let's hit render. Okay, and now I'm going to make it darker now. Not that much. I don't want to go in the negative region. It's probably too much. Yeah, it's too much. So you guys get the idea. We'll leave it at that. I think the idea is very clear. We're going to use the curvature to vary the shading on the rock. Okay, so what do we have next? Well, we can do a lot of things. The next thing I want to do is I want to vary the diffuse, and right now it's set to 1. And I want to add a little bit more variation to it. And what I'm going to do is I'm going to take the final result, whatever I have. I'm going to take the final result here and desaturate that. Sorry. And desaturate it. And let's take a look. It should give us a black and white map. Cool. And I want to use this information in to vary the shading. Now I'm going to add a little bit more contrast. Maybe more gamma. Yeah, gamma works. But I don't want to make them too much darker. I'm gonna put down a range, and let's say I'm gonna go above 1 because it doesn't really matter in this workspace. I'm gonna set it to 0.8 and 1.5, and let's connect the one channel. Only care about one channel because it's a float. And it's too bright here, so let's set this to 1, maybe 1.1, 0.7. Cool, and that creates a little bit more variation. We have to tweak this guy a little bit more, tune it down because I think it's too bright. Cool. And I feel like the texture could be lifted all together. So I'm going to do that here last. I'm going to add a little bit more contrast. A bit more saturation. And you can see how much options we have now. You can do all kinds of tweaks. And let's do a full res render. And I think we're getting close to finishing the diffuse component. I'm going to pause and do a high-res render, and we're going to continue playing with the diffuse component. So now almost took 5 minutes, 6 minutes, and you can see this is rendered at 2400 by 2700. And there's a lot of cool details. Now, the curvature feels a little bit too extreme. I think, see these kind of noise here? I think it's coming from the curvature. And I'd like to see a little bit more stripes. But I'm not going to worry too much. I'd like to continue adding the ideas that I have for this asset, and then we can go back and refine everything we need. I also think that the environment light is a little bit too strong compared to the sunlight, and I'm going to reduce it down a touch. So let me snap this to have a copy, and I'm gonna reduce the render settings. I also increased the camera. Come on, what's happening? I also increased the camera and added 2 diffuse bounces. And the resolution is scaled up, so I want to change that back. And with the light, I'm going to reduce it down. So let's go with 1, maybe 1.2. Yeah, and we'll try to keep this consistent. And let's go back to the shop context. I'm going to limit it to a specific region. And what I'd like to do now is I'd like to vary the color based on the normals. So I'd like to add green stuff, some kind of mosses on the faces that are facing upward. And how we're going to do that? Well, the easiest way is to take the normals and compute a dot product. And the way to access normals in Arnold is using the state vector. I'm going to set this to shading normal, and then using a dot product function, and let's connect this to the surface, and boom, we have a dot product function. And I'm gonna set it to only face the Y axis. And what I use this for generally is I would fit this into a range that goes from -1 to 1, because that's what the range is. That's what the dot product result is. So we have this, and then I use that to a fake sky lighting. So you can connect RGB map, and let's set this to, let's say, brown, and let's set this to blue. You can see we're gonna get some kind of sky lighting on this, and we can play with the range, and this will allow you to control basically the faces that are facing upward and the faces that are facing downward. And looks like I'm going to delete that, and basically you guys get the idea. We can remap this to red and green for the stuff facing upward and downward. And I'm going to put down a ramp, not an RGB ramp. Oh, actually it doesn't matter. Let's put down an RGB, and I'm going to move this. Yeah, this is a bug with the APR. Let's create a new one. I'm gonna move this to isolate the faces that I want the mosses to be on. And I think something like that is good. Okay, cool. And what I want to do is I want to take that color information, which is this guy, and I'm gonna use this information to vary that. So let's create another color correct and correct this to look green, and then I'm gonna use a mix between this and this green version, which we still have to set. I'm also going to change the diffuse guy to use this result. So I want the diffuse values to always be computed using the latest result. And let's move this to the side. And let's connect the red channel into this. Cool. So let's take a look at the result we have. Nothing changed because we didn't change the color. And let's start adding some green to it. Boom, there it is. Now we're coloring the parts that we want with green. Okay. Now the next thing I want to do is I want to change the color based on the height of this. And I'm going to use the shading position, which is not great, but later maybe we can add a rest attribute that stores the current position, and that way whenever we move the asset it's not going to change, because the shading point in object space may change based on the location of the object. Cool, so let's refine this a bit. I'd like to add a softer transition here, and let's desaturate the green a bit. It's not changing. I guess that's because it's all coming from the multiplier. Yeah. Okay, something like that. And the next thing is I want to change the shading so it's darker at the bottom and lighter at the top. And I'm going to use the state again, state vector. And this time I want the shading point in object space. And let's take a look at this vector here and see what we get. So you can see it's red, green, and blue, and we're interested in the green. So let's fit this green here. Range, let's fit this range, this guy, which is XY, this guy, and let's fit it between minus 1.5 and 1. Boom. I just want that to be darker. Actually, this tone is perfect. I'm not going to change it. The only thing I want to add is a little bit of noise to this because it feels too uniform, and I want to add some noise to it. So I'm gonna create a noise, set it to world space, set it to 10, 10, and 10. Let's take a look at the map if we want to. and add a little bit of distortion. Why is this driven? Doesn't make a lot of sense. I'm not sure why this guy is driven by... weird. And let's use this as a multiplier. Let's simply add it to all of it, and I'm going to change it to a vector because I want to distort all the position. Let's make sure we're looking at the red, green, and blue, and I want to add that to the vector. And then we want the green channel because that's what the Y position is coming from. Cool. Now you can see we're using that noise as well, and this is much cleaner than doing it later, because with the add we're distorting the vectors and then remapping the height, so it's much cleaner way of doing it. And then all we have to do is remap this a little bit to isolate it to just the bottom part, and then again use that to vary the shading on to make it darker at the bottom. So let's add a ramp. And actually I don't want the ramp, I don't want the bottom to be black. Come on. I want it to be white. Cool. And that's the area I'm going to affect. Or we can specify it here, but yeah, that's the area we're interested in. Okay, let's add another color correct, maybe copy this. So this is the result, and this is the new, where is it? This is the new value, and I want to use this guy to vary the result. Cool. And let's connect this to match that. Cool. Okay, now it's using the green, which looks cool. Yeah, I actually like it. Maybe we can do... my idea was to use something darker, but I really like the green there. Yeah, we'll go with the darker. But the green is cool. Maybe you can add it at the top. And now moving the ramp to affect a bit more the rock. Okay, I think we're done with the diffuse component. I mean, this is just the idea. I think the curvature is too sharp, so I'm gonna reduce it down. Let's set it to 1 and see what we get. I think 2 is good, and I want to see the difference, this guy a bit more, so I'm gonna increase the noise to 3. Yep, which I think I left it at 1. So this is what I wanted. I wanted something like this with cleaner lines, and we can still also distort this if we want to. Let me show you guys how we can do that. I'm gonna. Sorry, this is the idea I was going after with the stripes. And let me show you another thing. Let me copy this. And let's move here. And let's connect the noise. This is the result that we have. And I'm gonna create a state vector. Okay, and this is returning the ray origin. I don't need that. I want the shading position in world space. I'm going to connect that to P. Let's connect that to P, and we shouldn't see any difference. Now I'm going to create another noise, and this time it's a vector noise. I want to add that. Come on. And let's change this to world, and let's set it to vector. Cool. And let's increase. Nice. See the kind of distortion we're getting? That's because we're changing P. This is very similar to what we do in VOPs, in COPs as well. And let's change this. Let's add more octaves. Cool. Something like that. And overall, let's multiply this down because I think it's too strong. It's 0.2, so it doesn't distort these lines too much. And I'm gonna go with these guys because I like them more. So let's move this, and let's replace the clamp with this guy. And let's go here and connect this. Let me delete this guy. Okay, one more thing, the noise. I want to increase this a bit more. Where is it? Sorry, I deleted the wrong node. I need this to be here. So P, I want to connect that. Boom, there. I don't have a straight stripes anymore, which I think is a little bit more interesting. But you guys get the idea. You can do whatever you want. Now, what else do I want? I want something else. I want to add a little bit of bump, and for this I'm going to use the specular texture, which we haven't used yet, but it's let me show it again. Okay, so this is the specular texture, and I'm going to use that as a bump. And I'm going to copy this image here, and we don't need to be near that. We just need, actually we're going to use the curvature, so I'm going to be near the curvature node. Okay, so let's plug in the map. And I'm going to put down a call correct because we'll need that, I know. And let's create a tree planner node. Let's connect that. Let's take a look at the this map by itself. Okay. And let's change this to world space. Cool. And I think something like that. I want some big details. And I also want some fine details. So I'm going to copy this. And I'm going to set it to 5, 5, 5. It's a lot of tiling. Okay, like that. So I'm going to add both of them. And I'm going to multiply them. Actually, let's use the mix. We'll do the averaging. So I want to average both of them. Cool. Okay, and now I want to add nothing. I didn't change anything, so I'm trying to reproduce what I have already. And I want to multiply this by the curvature, so that the bump varies based on the curvature of the mesh. I'm going to use the red. These guys. I don't want to touch the edges at all, or whatever is in the green channel. I'm not so sure. And I'm gonna fit this because I don't want to use these guys from black and white. I just want a little bit of variation, so I'm actually going to invert it to not affect anything in the cavities and keep them clean. And actually I'm not gonna use anything else. I'm just gonna negate anything in the cavities to not be touched by the bump. And then we're going to put down a bump 2D node, connect the RGB color, and then we're gonna connect this to the normal of the BRDF. So geometry normal, and let's connect this guy. We're gonna see a lot more breakup, yeah. And if we turn on specular, it will help us see It will help us see more of this, and I'm gonna tune it down to something really low because it's very sensitive. You can see it's distorting the surface a lot. So I'm gonna set this to 0.005, and it's very sensitive, so it's obviously going to make the render slower because it's very accurate. Bumps in Arnold is really very high quality. You can see already we're getting a lot of cool details. Now I've added the specular to capture, to show you guys the kind of distortion. And even if we have super clean reflection, let's say with 0 roughness, you know what, let me do this. Let me add a specular AUV. Sorry, not that. Let me add a direct, specular direct and specular indirect. And let's take a look. So this is a super clean reflection, and because of that bump, it's getting distorted. It's getting a lot of noise, and it's gonna look rough. It's gonna look as if we have a glossy, blurry reflection. So we have to be very careful with this. I think it's still too sharp. This to 0.2. And we're just rendering a small section. So I didn't realize how, pardon me, how zoomed in I was. So I think we can go, it's very tricky with bump because once you zoom out, you're not going to see the same level of noise. And that's why when I saw the texture, I told you guys to be very careful, because once we zoom out and we have those texture tiled in and everything, it may get really noisy. But this detail is really cool. I think it's working nicely. Okay, let's do a high-res render, and we're going to continue. I'm going to rotate the camera just a tiny bit. I want to see this side. I want to rotate the camera to see the sun a little bit more. Or actually, you know what? I'm not going to do that. I'm going to go and rotate the light rig entirely. Yeah, something like that. Maybe 10. I want to see more surface lit with the sun. And I think the color is a little bit desaturated, maybe too much desaturated. I want to add a little bit warmth to it. Okay, I'm going to cancel this and change the resolution to 1.5, and set this to 4. Set the diffuse to 2. Actually, I'm going to set this to 1 just to keep it faster, and I'm going to hit render. So now the render is done. I'm not so sure how long it took, but this is what we have. It was super quick anyway, and I think we made great progress. There is few things that I definitely want to fix, and for example, I want to make the striping a bit more obvious overall, and I want to desaturate it a little bit. It feels too saturated for me. I want the color to be a little bit desaturated, and then I think the bump is a little bit too strong, because when I look at the specular direct, we don't have a lot of sampling, yes, but I think this is too harsh, and we need to tune this down until we see the correct specular value that we would expect. This would still be fine, but I think we can get more out of this, and you can see there's a lot of cool details here. Now let me show you what else I don't like. I think there's a lot of black values here, but again, we don't have any indirect coming back. We could still lift everything to look better here, But I think the main thing that bothers me a bit is the color are too saturated, so I want to fix that. But I'm not gonna spend time tweaking this. We still have the specular component and then displacement to add to this guy. The other thing, what was I talking about? Yes. So let's take a look at the sun light. This is just the sun AUV. You can see it includes everything, the indirect illumination as well. And then the environment, which looks really cool. I think with just a little bit of tweaking, we'll get it to look as way more realistic in terms of details. I think these guys are not fitting the environment perfectly. Maybe we can tweak the curvature a little bit more. And I feel overall that the surface feels wet, even though we're not doing anything to it. There is specular here, but it's not. If we look at the specular direct, you see the environment is really dim. We're not seeing that. So I think because of the curvature, it's giving us the feel that it's wet for some reason, or maybe just me. And then what I'd like to do is I want to continue working on this, and we need to add the specular component. So let's do that. And I think let me check a few things. Okay, cool. So the specular, we're going to reuse the same one for the bump. I think there is a lot of cool information there. And then I'm going to put down a range node. I'm going to use the same one. I don't want any specular on the cavities because it doesn't make a lot of sense to have them there. And then I'm going to, let me think. I'm going to connect this straight into the specular component. Specular, I actually just need the single AUV. And let me change a few settings back so it's faster to work with. I'm going to change this to 4, increase the specular to 3, set this to 1, and let's zoom in on a region, maybe this guy here. And what I like to do whenever I tweak the specular, I like to turn off any displacement because that will affect how I like to turn off any bump because that affects how the specular looks. And if I can just find where the bump node is. There. So to keep this value, I'd like to multiply this by 0, so I know that the previous value was 0.05. I don't lose that. And let's see. Make a few changes. So what I'm going to do is I want to use this fit range to change the specular, and I want the specular information to go from 0.5 to 1.5. I'm going to increase it, and these values are going to be fine as long as even if we go above 1, as long as it looks fine here, we're safe. I'm gonna make a copy of this. Actually, let's add a dot to make it easier to split. And I want to change the roughness based on this map as well. And for the roughness, I'm going to use 0.2 and 0.4. So it varies between based on the image. And I'm going to hit render. Cool, so we're getting a lot of specular now. And I want to keep it this way. And because of the bump being off, we know exactly what kind of details we have. And then once we turn back the bump on, it's going to get broken down. So I'm going to fine tune this so it doesn't damage the specular this much. Yeah, it's really high. You can see how much distortion happened to the specular. So I'm gonna lower this to 0.1. You can see the render goes faster as well because the normals are not changing as much, and so Arnold doesn't have to do a lot of extra computation to account for that surface details. And I think we're much better now. I'm gonna leave it. Let's change it to 0.2. And remember, we're zooming in really close to the geometry, and when we look at it, those details will not be that visible. It's going to be the resulting of that noise, fine details is what going to give us the appearance at the end. Let's take a look here. Yeah, I think it's working much better now. It's probably a bit too much, but it's fine. I'm not gonna worry too much for now. And I think we're getting some cool details from. Yeah, we're not seeing this much. Yeah, for some reason it looks much more desaturated than the previous one. Yeah, I like it now. Okay, so this is the beginning. And then what I like to do is I'm going to import a new image and use that to add more specular. And the one I'm going to use is this one. I will show you guys how it looks like. And we're going to actually tweak the displacement, or maybe, yeah, we're going to tweak the displacement first. Sorry, it's not this image. This is what we're going to be using for the displacement later, but that's not the one I'm going to add for the specular now. I've created a one that has some rocks on it that I'm gonna stamp onto this geometry to add more details, and I'll show you how that looks in a second. So this is how the image looks like. I don't have a diffuse for this. It's just this information. So I'm gonna copy this and hopefully get something interesting out of it. And we're also going to add it to the diffuse, so we'll touch both of them. And for now, this is the specular I'm going to use. I think it's working pretty well, and there's a lot of interesting details. I'm not gonna spend too much time on it, and I'm gonna import that image for the rocks. And let's take a look here, and let's put down a tray planner. And let's connect this. I'm gonna set it to 0.5. Pardon me. And what I'd like to do is, let's see. Okay, let's do more scattering. Interesting. Okay, I was not looking at the correct information. Sorry. So I'm gonna set this back to 0.5. Yeah, I want these kind of details on the geometry, and then I'm going to copy this and I'm going to make another one with more tiling. So 3, 3, and 3. And then I'm going to mix both of them. So I don't want the two together at the same time. I want either this or that, or they mix together. And then I'm going to use a noise to break this up even further. So let's connect the noise. Let's put a clamp, make sure our values doesn't go above range, and let's add some more details to the noise. And let's set it to 3, 3, and 3. Cool. And I'm going to use this to add also displacement to the surface as well as specular. So let's use it for the displacement. I'm going to create another standard. I don't want to use that. And I'm going to connect this to as a displacement. And the only thing we need to do is we need to create a float to RGB. We need to use a float to RGB node to convert this into an RGBA. To convert these guys into a vector, which is this. And then I'm going to connect this to the displacement. And I believe we need to hit render now, because with the I can't remember. With the displacement, we have to use the original geometry and have sorry. Let me first verify that it's working, and then I will explain what we need to do. Let me move this here. Let's snap this guy. And let's turn off displacement. Okay, so it's not working. Let's add a multiply and add more values. Let me turn this off and re-render again. Now the displacement option is in the object properties, and we don't need any subdivision on this because the mesh is already very high res. And let me show you this. So when I create a geometry node and go under the Arnold, there is this displacement options here. We need to tick on auto bump. And I also like to tick on auto bump shadow rays, and we don't need any subdivision. We just need this option here to know where to displace versus where to use the auto bump. And I don't think this geometry had that on when we exported it, so we need to export it again. Let me turn this off. Turn this on for both of them. And let's export this. Let's do it on both. I can't remember which one exports the geometry. And if we go under base here, okay, export shape, export shaders, that's fine. And let's change the version to 2. Okay. Let's hit render. And let's go to this guy and change the version to 2. Cool. So everything seems to be fine here. And let's go to the shader again. It didn't export the geometry, so we have to hit render again. And I'm trying to think if there is another option that needs to be turned on somewhere, but I don't think so. Cool, I think it's working. Yeah, so let's set this back to 2, 2, and 2 and hit render again. It's obviously going to take longer for it to start because it needs to displace the geometry and then render that. Still rendering black. I expanded the region. I'm gonna turn off the sky to see if we're getting anything in the alpha channel. Maybe it's displacing the geometry too far, that it's causing this issue. Yeah, it looks like it's doing something, but I can't tell. So let's do one more thing. Let's go back to the shop level, and let's reduce this to 0.2, and let's hit render. It's definitely doing some extra computation, but it's hard for me to debug it because I lost the shell, so I have to close Houdini and start again. Yeah, something is not working correctly. Okay, I'm gonna pause and we'll figure this out and come back. Thanks, guys. Hey guys, welcome back. So I found what the issue is, and what was happening is the mesh was getting displaced too much, that to the point that we don't see anything, and we were inside the geometry itself. It was getting displaced to the point where it's beyond the camera. So what I've done is I tweaked the settings for this. So if I go under displacement, it's 0.001 instead of 1, and added a little bit of padding here, and then I exported the geometry again, and that's what I'm using now, one with these settings. And let's see, and then I tried with adding details with the texture that I showed you at first. Where is it? So let me show the texture. One of them is not working. I'm not going to spend too much time because already having this is not very interactive. So I was trying with this to add a little bit more displacement, but it was not working as expected. So I'm not going to use that. I'm just going to use the one that has the rocks details, and that now has 10 by 10 by 10. You can see it's adding a little bit. You can see it here. You can see it here, and that's all I'm going to use for now. And I'm quickly going to turn off the displacement because it's not very interactive, and Arnold has to subdivide every time. So if we make a change or anything to the displacement, we have to not subdivide, but it has to displace the mesh again, and it's not very interactive, so I'm not going to keep doing that. The thing I'd like to do is I'm going to add the displacement map for the rocks to the specular, so we can capture some specular in there, and then I'm going to use that with color correction as well to add a little bit of variation to the diffuse. So I'm going to add here, where is it? I'm going to move these guys. I'm going to add a color correction to this, and then mix between the original and the color corrected one using the specular mask, so this guy, and we'll change the color to fit what we need. Cool. So I'm gonna connect that, and let's plug in the shader, and the displacement is cool, the bump is cool as well, so we'll keep that, and let's hit render. I'm gonna change the background to have the sky to have the image back. Sky, cool. And I'm not gonna keep hitting render to see the displacement or push it. I'm just gonna work on the shader now, and I think it should be fine. And we just need to make the color changes here that we need to make the rocks appear a little bit, and that's it. So let's try and make them first different colors so we can see the details. Yeah, there they are. We could probably add a little bit more as well, but I'm gonna make them brighter overall and make them show up. Something like that. And then we can use this result also in the diffuse value, so we get more diffuse in there. Cool. So let's connect this. We should see, we should see some details in there. It's probably too much. So let's tune it down. And because the mesh is really high res, we don't have to subdivide it. You only subdivide it if you don't have enough geometry, but in this case the base mesh was 3 million polygons, and I'm not going to subdivide that to add fine details. And I'm actually going to turn off displacement for this one because the overhead is too much, especially if we're going to see it from far away. I don't think it's worth it. But I just want to show you guys how it works and the idea behind it. I mean, the render time is not slow. You can't call it slow because I just want it to be faster so that you guys don't have to wait too long, and it's much more easy and attractive to work with. But I'm gonna do a render. I'm gonna change the settings. I'm gonna increase the displacement a little bit more. I want these guys to pop out a bit more and have some more shadows, so increase this to 20. And I want to desaturate the surface a little bit overall, so I'm gonna do that here. Let's see how this affects. Let's see if we desaturate it completely, what we get. Still interesting. And I think the gamma is too much, so I'm going to increase. Yeah, something like that. And let's do a high-res render. Render is done, and I have another older version rendering, actually the original version I did. And I really like the end result. I think it's very close. I mean, we just spent like an hour and 30 minutes probably on this. And you can see now with the displacement added, we're getting all these fine details added to the mesh, as well as the shading. The shading also helps a lot bring them up, and I think it's adding a lot of cool details. Now it's obviously a little bit heavier. You can see here there is some really cool parts that without them we're missing one level of details in this mesh. Now what I wish I had time for is actually adding real grass to these sections here, and you can easily isolate them using the normals and probably just paint them by hand, like this guy, and add actual grass, scatter actual grass on them. And then for the bigger section, like here for example, I would scatter some extra rocks that are shaded differently. That means they've been falling and they have get stuck. They got stuck here, so you can add all kinds of extra geometry to make this look really realistic. and anywhere that makes sense basically. And let's see, so I think there is a lot of information here, and let's see, I think the environment light also looks really cool. I think this is very realistic by itself. And this is the sun with the indirect illumination, which is cool, and then everything together. Now I have, let me show you the raw render and to talk about the specular a bit more. Now this is with the, let me change it to sRGB. Yeah, so this is sRGB, and you can see how everything is flat. There's no, I mean, we didn't light it to look good in this environment, so we'd have to go back and tweak some of the things. But let's take a look at the environment light by itself, and maybe add a bit more contrast to it, something like that. I think this one is capturing the details, but the sun is not. So look at how clamped these guys are, and we're not pushing too far. We're not going to the extremes in this example, but we will in some other just single scenes do that. And look at how flat the render is and how clamped the values are. And once we go back to the Opencolor IO, look at how beautiful this is. Everything is just works, and all the values looks much more natural now. We have more variation, have more information from black. We have a full range of values, and look here, for example, we're getting a lot of nice details, even if it's super tiny. Look at this, for example, and all that is a mixture of the specular, diffuse, all the information that we have in the shader. Now let me show you guys the older version. This is the older rock. It's pretty much the same shader, just few values are tweaked differently, few color correction. I like the stripes a little bit more here. I like the desaturation a bit more, but overall it's very maybe a little bit more contrast here, but overall I think it's very close, and I'll be sharing both scenes so you guys can take a look at them and compare them. I think that's pretty much it for this scene. In this video, I wanted to talk about the content and you guys should work on for this week. I think the highlights is being able to generate a low-res mesh that you then create a UV for and try to bake the texture and reapply that in the scene. You don't have to do it in the render, but just try to get the low-res with displacement added in SOPs to match the original mesh. And then you can export that original mesh. For example, this is the final version after displacement applied to it, and it has a perfect UVs, even though I didn't use it. I want you guys to do that, to go through the process, but you don't have to use any render time displacement. Just export the map, take your high-res geometry, low-res it, export the displacement, apply it back to the high-res, and then export the high-res with the UVs on them. Then do the shading using the various maps that you've created and try to come up with something. The technique that I showed in terms of UVing should work with anything that is basically similar to this. We're going to talk about another technique in week 8. I can't remember. 1 second. In week 9. So week 9, we're going to dive deeper into the UV creation, and hopefully in that week we're going to learn a couple more methods that can solve dealing with a variety of other complex meshes. And then once you have the high-res mesh, you can start shading it. If you're not very interested in doing the UV creation and the low res and applying it, that's totally fine. If you just want to focus on the shading pipeline as well, that's totally fine. If you do that, you have to shade more than one asset. If you don't do the UV process, you need to shade at least 3 or 4 different assets during that week, and then basically try to use the same techniques that I showed in this week. And in the next one, we're going to dive deeper. I didn't want to go over a lot of details this week. I think this is enough to get started with, and then make sure that you get the ASYS workflow up and running and installed. And I think that's pretty much it. Thank you so much for watching, and talk to you soon. Bye-bye.